Well, hello again. This is Sunday evening, and thank you, Ben Curran, for letting me know that my video on YouTube cut off right here after I did the whole thing and didn't realize that it had cut off. So here we go. This is finishing up this last problem. 15 over 9 times 36. I would certainly tell you to leave it like that, but I guess if we want to clean it up, we might say that 3 goes into 15 5 times, 3 goes into 9 3 times, and it looks like we might have 5 over 108 as a nice simplified answer. Okay, next page. Here we go again. So we've got f of x that is given to us on a graph, and g of x and g prime that is given to us in a chart. So BC1 says write an equation of the tangent line and use this line to approximate g of 2. So here we go. G of 3 looks like that's equal to 5, and g prime of 3 is equal to negative 2, and so our equation of our tangent line would be y minus 5 equals negative 2 times x minus 3. Using this to approximate 2, we get y equals negative 2. Plugging in 2, we get negative 1 plus 5 equals 7. So g of 2 is approximately 7. My question would be, is there enough information here for us to be able to tell whether that is an over or under approximation? And because we don't have any information on g double prime, we would say no. Okay? And then let's go on to BC3, where we're talking about continuity. In order for a function to be continuous, the limit has to exist, the point has to exist, and the limit and the point must equal the same value. So let's first of all do a limit as x approaches 3 from the left. That would be this little piece right here. And so f of x times g prime of x. So f of 3, and I don't know why I have a little plus there. Let's go minus. So x approaching 3 from the left, f of 3 from the left, I'm going to come right in here like this, is approaching negative 1. And g prime of 3, it looks like in either direction, would be negative 2, and so our limit as x approaches 3 from the left is 2. Our limit as x approaches 3 from the right then would be of 4 times f prime of x minus 3. So f takes us over to the graph, and as x approaches 3 from the right, when we plug in 3, that's f prime of 0. F prime of 0 is right here. We want the slope of the line right there, and it looks like our slope is 1/2. So 4 times 1/2 is 2. So our limit exists, and our limit is 2. Now, you can go ahead, because this part right here says equal to, we can plug in 3, and 4 times f prime of 0 is 2. And so because all 3 of these equal, then we would say f or p of x is continuous at x equals 3. Very good. Okay, another graph. On what open intervals is the graph of f both decreasing and concave down? Give a reason for your answer. So from negative 2 to 12, let's look at f prime. This is the graph of f prime. So from negative 2 to 1, this graph is above, so that's positive. And then to 9, it's below, is negative. And then from 9 to 12, oops, it's still below, so it's negative. So positive, negative, negative. Okay, now let's look at f double prime, which would be the slope of this graph. So we're looking at where the graph is increasing and decreasing. So the graph is decreasing all the way to 7. Then it increases to 9. And then it decreases. So the graph wants decreasing and concave down. So decreasing would be f prime is less than 0 and f double prime is less than 0. So let's look at our graph here. It looks like from 1 to 7, both the first and the second derivatives are negative, and then again from 9 to 12. And we've got our reason right there because the first and second derivatives are both less than 0. G of x is the product of f and f prime. So g prime of x, we're going to need some product rule here, is f times f double prime plus f prime times f prime, or f prime squared. Okay, g prime of 4 will be f of 4. So I'm looking at this. This is my graph of f prime, and it's wanting me to do f of 4. And I'm going, how the heck do I know what f of 4 is? Oh, let's read the whole problem. They're going to give it to me somewhere. Don't panic. F of 4 is 14. So 14. G double prime of 4. So let's go over here to 4. Right here. So what is the slope of that line? Let's see. From 0 down here to 4 is 4. And from 1 to 7 is 6. So I would say that that's negative 2/3 or 4/6. And then plus f prime of 4 is exactly the point there, negative 2. So plus negative 2 squared. And if you're anything like me, you're going to keep it messy and move on. So 14 times negative thirds plus 4. Okay, average value of f prime of x over the interval, or excuse me, f double prime of x over the interval from negative 2 to 12. Okay. So remember when we talked about the average value, let's talk about the average velocity. Average velocity was change of position over change in time. So the average value of f double prime is going to be f prime of 12 minus f prime of negative 2 all over 12 minus a negative 2. Okay, so we're going to go to the graph here. F prime of 12 is, looks like negative 2 minus f prime of negative 2, which would be negative 1 all over 14. And it looks like I'm getting here, what, negative 1 over 14. So let's kind of move all this off here, and let's look and see if that makes sense. Negative 2, negative 1, and 12. So what does the slope of that look like? Do we look like we have a negative 1 over... I didn't go far enough, did I? And I didn't get my negative 2 right. Let's come over here. Negative 2 took me all the way up here to 4. So, I like that answer better. Negative 6 over 14, or negative 3/7. Okay, better. Sorry about that. I did 2 instead of negative 2. Okay, moving on, nothing here. This is all second semester, good stuff. All right, using the data in the table to estimate k prime of 3. So we want to go as close to 3 as we can. That would be 2 and 4. And so k prime of 3 is 5 minus a negative 1 over 4 minus 2, or 6 over 2, which is 3. So k prime of 3 is approximately to 3. And hopefully we've done enough of those that now you're comfortable with them. Is there at least one x from negative 2 to 6 such that f prime of x equals 5? So we're still on k, or excuse me, h. We're over here. La 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 la. There we are. Okay. And what do we know about this? This is a differentiable function. So k prime is differentiable, therefore is continuous. And we can use the intermediate value theorem. So do we pass 5 somewhere? Sure we do. If we're continuous from 3 to 6 and we pass from 2 to 7, we must cross 5. So let's say this. Because h prime of 3 equals 2 and h prime of 6 equals 7, then h prime of x equals 5 between 2 and 6. But again, you have to say that it's continuous to use by the intermediate value theorem. Okay, now we're going to go to h double prime. And I know that this seems weird to be using the mean value theorem, but we are talking about the derivative of h prime. So we're looking, where does the slope of the tangent line equal the slope of the secant? We're looking for the slope of the secant to be 1. So you kind of have to look for a few minutes between your x and y values and try to find 1. There's a couple of places on here that works. The one that I saw was negative 2 to 2, because your change of x there would be 4, and your change of h prime would be 4 also. So again, k prime is differentiable, which implies continuity. So we can use the mean value theorem. So let's talk about this. H prime of 2 minus h prime, here goes the pen again, h prime of negative 2 all over 0 minus a negative 4. So I have 2 minus a negative 2, which is 4 over 4 equals 1. So we've got that slope that we were looking for. So our slope of our secant line between 2 and negative 2 is 1. Therefore, there must be a value of x where h double prime of x equals 1 as well by the mean value theorem. So between 2 and negative 2, h double prime of x equals 1 by the mean value theorem. There we go. All right, hopefully we're coming down here to the wire. Write an equation for the tangent line at k at x equals 4. Use the approximation to, or use the equation to approximate f prime of 2, and then tell me whether the approximation is less than or greater than the actual value. We will explain our reasoning by the second derivative. So let's go back up here to k. We need k of 4, and we need k prime of 4. So let's see where we are. We're right here. K of 4 is 5, and k prime is 12. All right? So our point is 4, 5, and our slope is 12. So y minus 5 equals 12 times x minus 4. y equals 12 times 4.2 minus 4, which is 0.2, plus 5, and that's going to give us 7.4. Okay, now let's go back up here to our second derivative. Our second derivative up here appears to be greater than 0. So because k double prime is greater than 0, k is concave up. I always like to look at what concave up looks like. Our tangent line is below, and so 7.4, our approximation, is actually less than k of 4.2. All right, and then I think our last question down here is just a chart problem where we're finding the derivative. Again, this could have been on your last test. G prime of x is e to the f of x times f prime of x. There's our chain rule. So g prime of 6 equals e to the f of 6 times f prime of 6. Let's go to the chart and go to 6. Here we are. So f of 6 is 5 and f prime is -3. So our answer is -3 e to the 5th. And hopefully this